Hey friends, welcome to follow up. Let's have a look at today's daily challenge problem. Problem 1312. Minimum insertion steps to make a string palindrome. So in this video, we're going to explain a solution based on dynamic programming. Actually, we need to first transform the problem and then do the logic. Let's first have a look at the problem main statement. So here we are given a string called s, and in one step we can insert any character at any index of the string. So we need to return the minimum number of steps to make s palindrome. So here a palindrome string is one that reads the same backwards as well as forward. So here we have three examples. The first example is very special because the string itself is already a palindrome. So we just need to return 0 in this case. And in the second example, so we know M and M are the same. So actually we can ignore these two letters. And then we have B and D, they are different, right? So we can add a B in the after D, and then we can add D after B. So this way we get a palindrome. So the output is 2. So in the third example, the output is 5. So if you examine this example, you can check that to the longest palindrome subsequence in S, the length will be 3. For example, you can choose E, 3 E's. Or you can have ETE, right? There also the length is 3. So the palindrome, the longest palindrome subsequence from S, this object is not unique. However, the length, the longest one, will be unique. So notice that the length for this S is 8, and the longest palindrome subsequence length is 3. So we get 8 minus 3 is 5. So this is the logic for this one. This is also the logic we are going to code. So before we look at the coding part, so here the additional assumptions are the following. First, the length of S is in between 1 and 500. So 1 tells that this string is not empty, and 500 tells us the upper bound or the problem size of here. And the second assumption or constraint is that S consists of lowercase English letters. So this actually is not that essential, right? As long as it contains ASCII characters, that will be fine. So now let's look at the problem logic. So overall, what we are going to do is the following. So we want to use dynamic programming. So this is our treatment. So the thing is that what we want to do is that we find the longest palindrome subsequence from S, and then so we find the longest palindrome. So what we are interested in is the length. Find the length of the longest palindrome subsequences. Maybe this is more precise because the longest palindrome subsequence or sequences might not be unique. However, the length is the same, is unique. Then let's find the length. Let's call this length as ls. So we just need to return the length of the string given, that is S, minus the length of the longest palindrome subsequences. So this is our plan. So in order to get the length of the longest palindrome subsequence from S, so this is a standard dynamic programming problem. So with that said, basically we just need to use the code for finding the length or the longest palindrome subsequences from S, and then we just do this return. That will be the overall structure of this coding exercise. So here, as a first step, so we want to do DP to find the length of longest palindrome palindrome subsequence or subsequences. Let's see. This is more precise, right? So here, let's define the length of the longest palindrome subsequence. So the sequence is different from substring. Subsequence is different from substring in the sense that substring should be continuous. In other words, it's indeed a substring in the sense of string comparison, right? So here, let's input this as what we are going to return is the length of the longest palindrome subsequence. So in order to find the longest palindrome subsequence length from S, so we can consider its reverse. That is S. Let's reverse that. So we just need to find the longest common subsequence from S and T, right? Because T is the reverse, then the longest common subsequence of S and its inverse will read the same from forward and backwards. That's actually suits the problem. So before we write the code, actually we want to point out that so this if we want to consider longest palindrome substring, that will be quite different, right? So this is the point to notice if you have practiced quite a number of problems, like problems in leetcode. So now let's come back from the detour. Now let's I'm going to have a length that is S. The length is n. Also, the length of t is n. So in order to easily use this, we can imagine, right? So we can imagine S is something like this. So we can insert as beginning something special, right? Then plus S. So this is the S. And the T we can regard as some special character different from this star and different from this lowercase characters as defined here. So let's put a ampersand, so plus T. Then we want to find the longest common subsequence of this updated versions of S and T. So they're the same thing, right? So we regarded this as corresponding to index 0. So this is just some subtle details for the treatment. But you know, sometimes it can be tricky. So now let's use a DP table. So here I'm going to do this. So the length will be, the column length will be n plus 1. And for a dummy index in range, so I'm writing n plus 1. Then in general, I would consider the dp will be dpij will be the length of the longest palindrome subsequence up to index I minus 1 in S and up to index j minus 1 in T inclusive. So this is our interpretation. So this way of interpretation and adding this star and ampersand is easy for us to do initialization of the DP table and the update. And because if we consider corresponding to index 0, so we will get this one, right, star. There's no star in T, so the common subsequences for S and T will be 0. So this corresponding to first row to be 0, and then also there's no ampersand in this S. Therefore, the first column is 0. So we use this this initialization automatically. So this is a small detail. Then we're going to iterate, right? So this is the very standard now for I in range 1 to n plus 1. Then similarly for J in range 1 n plus 1. Then we want to compare the current characters from S and T and make a comparison. So notice that for dpij we are consider this the index and this index of characters. So if S I minus 1 equals T j minus 1, then the dp update rule is like this. So we have dpij equals dp I minus 1 j minus 1 plus 1, because this index I minus 1 and j minus 1, so the two characters coincide. So we extend the length of the longest common subsequence by 1. Otherwise, so we are going to have ig. So because current one cannot be counted, so we want to pick the maximal of dp I minus 1 j and dp I j minus 1. In other words, we first try, we do not use tj minus 1 corresponding to this one, and then we try, we do not use so here with this one is corresponding to not using si minus 1. This corresponding to not using tj minus 1, right? So afterwards, we just need to return dp negative 1, negative 1. So this dp negative 1, negative 1 will be the length of the longest common subsequence for S and its inverse. Therefore, it's the longest palindrome subsequence length. So with that done, basically we do the return. In this problem, we just need to return the length of this S, and then minus the length of the longest palindrome sequence of S. So this is the problem logic. So before we make comments, let's first do a check. Yeah, it passes example 3, I guess. So now let's look at the generic case. Yeah, it passes all the generic cases. So here, basically, we use dp to solve a transferred problem. That is, find the length of the longest palindrome subsequence. So in order to do this, actually we transformed the problem again to be that we want to find the longest common subsequence of two strings, right? But here the two strings come into play are special. One is the string itself, one is the string, the inverse, right? With that done, basically that's routine to do the return. So that's about it for this video. If you find this explanation of use, you can follow me up in my YouTube channel. Thank you.